Okay, so I'd like to start my discussions with the rebus puzzles that I have here for you. So we check into what could be the possible message for us or the phrase that being told by these pictures. First, we have the word God and we have the word hero. Now you examine that the word God, same with hero, are repeated. God is repeated 4 times and hero is repeated 10 times. So using your analytical skills in this manner, so we can say that this picture tells us about forgotten heroes. So forgotten heroes, in short, forgotten heroes. Another is you have the word moral, and then you got there a figure. It's like it seems it's a rectangle supporting moral. So the word moral should be inclined. And analyzing the picture, we can have the moral support. Another, the picture shows a relationship between the number and the letters through a representation of a fraction. So the numerator, you have the number 1, but repeatedly once. And in the denominator, you have the word time. So once is on time, once is upon the word time. So we can say it's once upon time or once upon a time. Now, with the 3 puzzles that I presented to you, we tried to analyze the relationship of the terms so we can come up with another message or another phrase for us to look into consideration. And that is what we are to do with this lesson. Suppose we're given a triangle and we can name this as triangle A, B, and C. So you notice that the angles are named using the capital letters A, B, and C. With the corresponding sides opposite those given angles, we have the small letter A representing the opposite side of angle A, the small letters B for the side opposite angle B, and the small letter C for the side opposite angle C. And you can have here a right triangle or a right angle. Okay. Now this angle is there, a right triangle. And a right triangle, we can solve for the parts of this using what we call the SOHCAHTOA. This is what you learn in your plane solid geometry. No, plane solid trigonometry rather. Plane solid trigonometry. It's also do appear in geometry as well. So the SOHCAHTOA, sine equals opposite, hypotenuse, cosine, adjacent, and hypotenuse, tangent, opposite, and adjacent. As we move into, okay, now, what if your triangle is now not a right triangle? Let's say you got an oblique triangle. Still, the relationship or the pair, angle, pair, side, the pair of an angle and the opposite side, and another angle and the opposite side of it is very important in solving oblique triangle. But this time we can't use your what we call the SOHCAHTOA. We can't apply that. There are another law that we can use here, which is first what we call the sine rule. The sine rule is applicable in the cases that we've known, like AAS, or when given 2 angles on one side, or SSA, given 2 sides and a non-included angle. So when you say non-included angle, that angle is not within or not in between the 2 sides, or that angle is not being made by the 2 sides. Okay? So it's like, let's say that angle could be opposite of another side or one of the sides that's given, but it's not in between the 2 sides. So non-included angle. So remember what I've told you? The pair that you have to make, you should have at least a pair of a side and the opposite angle, another side and an opposite angle, and another side of an opposite angle. So they are all equal when it comes to this sine rule. Let's have this given. So given triangle CAT, wherein the measurement of angle C is equal to 30, we can see it here, 30, and then side A is 18, side C is 14. You're asked to solve for the measurement of angle A. So using your sine rule, side A all over sine A over side A over sine A equals side B over sine B, the angle, equals sine C over sine C. So side C over sine C. Now, with the given figure, we can use this, since we're looking for the measurement of your angle A, so we can get this angle A and the opposite side 18. So we have A over sine A. And then for B over sine B, we don't need this anymore since it's okay and we are not being affected by it in solving for the measurement of angle A. And we can, after knowing that we can use this, we can get rid of that. Move to the next, C over sine C. You can see that we have a given angle C, which is 30, and there is also your opposite side 14. So we can use the relationship of A over sine A equals C over sine C. So since we have that transitive property, let's say A equals B equals C. If A is equal to B and B is equal to C, therefore A is equal to C. Similar here. If this, let's say this is A is equal to B and this B is equal to C, therefore, we can also use that, we can say that this A is also equal to C using that transitive property. That's the reason we can come up with A over sine A equals C over sine C. So let's apply that in solving the word problem, or I mean the given problem with us. Given triangle CAT, wherein the measurement of angle C is 30, A is 18, C is 14. Solve for the measurement of angle A. So the sine rule, okay. By the way, how come that it's really sine rule? Go back to the second case. We have said that in sine rule, we can use if there are two given sides and a non-included angle. Now, looking at this is a side and another side. So we were really able to satisfy that first statement. Given two sides and non-included angle. 30 is a non-included angle. Okay? If this 30 is here, then we can say it's an included angle. But since it's here and it's not an angle formed by 14 and 18, based from the definition of an included angle, whereas an included angle should be made by the two rays that met on a that will meet on a certain point, and that point will make up an angle. So since it's a non-included angle, we can say that we are really using sine law. So we replace now the values. For side C, we have 14, sine C, so sine 30, equals A is 18 over sine A. So sine A, we're looking for the measurement of angle A. This is a simple fraction and another simple fraction. Recalling your rational expressions, you can simplify this by applying your cross multiplication. So when we cross multiply, you'll have now 14 times sine A, so sine 14A, 18 times sine 30, 18 sine 30. Our aim is to get sine A, and you have 14. So the question is how you can get rid of this 14. So you can get rid of this 14 You have to make it 1. So you have to think of, how can I make it 1? How can you make 14 equal to 1? There are two ways. Yes, you can divide it by 14. So 14 divided by 14 is 1. Or you can multiply it by 1 over 14, where is 1 over 14 times 14 is 1. So any of the two can be applicable. But that's what we are calling 14 divided by 14. You divide this by 14, you divide the other side by 14. So you are applying division property of equality. You have the word equality since you're dealing with an equation. So you can use that, or if you are comfortable with MPE, the multiplication property of equality, you multiply this side by 1 over 14 and also the other side by 1 over 14. So upon doing that, you'll have sine A equals 18 sine 30 over 14. Now again, we're looking for the measurement of angle A. So there goes your calculator now. And we have A is equal to sine raised to negative 1. So this is arc sine. Now, all you need to do is to get your calculator this time, and then you plug in now your values. Okay, so let's plug in now the values for us to get your sine or your angle, measurement of angle A. So we can have here sine, arc sine, then we got 18 sine 30. Close in parentheses, divide by 14. So in this manner, you can see that this calculator can be very parenthesis sensitive. So it's not that advanced comparing to other calculator. This is a basic scientific calculator. So it depends upon the calculator that we are or you are to use. If you're using ClassWiz or another type of calculator. So some calculators don't need that much parenthesis. Those who were equipped of that advanced functions. The other calculators might be needing that more parentheses. Okay, so you don't say that your calculator is wrong if you don't get this similar answer. It's just that we have to take into considerations that there are calculators that's equipped without too much parentheses. It can calculate all throughout, and there are some calculators that needed parentheses to group the terms. So approximately the measurement of our angle A, okay, and where's my screen? Okay, so we can say that the measurement of our angle A is approximately 40 degrees. Okay, so 40 degrees. Now, let's have another example. Let's take a look at this soccer player who takes a shot on a standard net that is 7.3 meters wide. If the player is 10 meters from one goal post and 14 meters from the other, through what angle can a goal be made? So you have to analyze, and if the sketch or a sketch or a diagram is given to you, it's easier. But if it's not yet given, so you have to visualize how it looks like in real life actions. So like this is the angle that we are to look for. Now analyzing, we have again an oblique triangle. So we name the sides. All the sides are given, so no angle. So definitely we cannot use your sine law. What we can use is another law. So we can't use the sine law, it's obvious, no? Angle, angle, side, angle, side, angle, side, side, angle. So definitely we can't use that. So we have to take into consideration another rule, which is the cosine rule that is being used given two sides and an included angle and given three sides or SSS. So this time we are given three sides. And that's a relationship that you're to use. You take note that if there is a missing side, that missing side is equal to the given opposite side of it. So here, we're given three sides. Analyzing it, let's say we name that angle as cosine A or angle A, the angle that we are to look into. This B squared and C squared are the two angles, are the two sides rather, that's given. And then you have minus A squared. This A squared is the opposite side of that angle that we are to look into, divided by 2 times BC, the other two sides. So let's apply that with our example. So since three side lengths are known, so we are to use cosine rule and go back to the question, through what angle can a goal be made? So you have cosine A equals B squared plus C squared minus A squared all over 2BC. So we replace now all the A, B, C with the corresponding values. So you can see it here. You have 14 squared plus 10 squared minus 7.3 squared all over 2 times 14 times 10. And we have A equals cosine raised to negative 1. So again, this time you can use your calculator and then you enter again the data. And upon doing that, you should be having an answer of approximately 30 degrees Celsius. So since it's a word problem, it's a must to answer your question through a conclusion. We can say that to score a goal, the player must shoot the ball through a 30-degree angle. So for those soccer players, maybe you can take this into consideration. Calculating, estimating the goal. So with the two laws, you have to remember the difference. The sine rule, merely there is a given angle or angles. For cosine rule, there is a given two sides also and an included angle, wherein the sine rule given two sides and a non-included angle. So take a look into consideration of that. And also, if you're given three sides, that goes for cosine rule. Okay, so those are the major differences between the sine rule and the cosine rule. Aside from the sine rule and the cosine rule, there is another rule, but sometimes this is not being discussed like thoroughly. So I'll just give you a glimpse of it. Maybe I can stay here. There. So this is the laws of tangent. So it will represent the relationship between the tangents of two angles of a triangle and the length of the opposite sides. So it will describe the relationship between the difference of the sum of sides. So let's say you're given a side A and side B. So the difference of that side would be A minus B. And then sum of sides, side A, side B, so that's A plus B. That also goes with the difference and sum of corresponding angles. So let's say side A corresponding angle is B and so on and so forth. So the difference would be A minus B, the sum would be A plus B. And we got this concept from the congruence, they call this relationship. Okay. So here, as we are talking about, difference and sum of sides and difference and sum of angles. So let's apply that with our triangle. Solve the triangle ABC. Given A is 5, B is 3, and the measurement of angle C is 96. Find the value of A minus B. Now let's use now your tangent law or law of tangents. Since we have the side A, side B, so we can use that A minus B, A plus B. But the problem is we don't know A minus B for the angles and A plus B for the angles. We all know the measurement of angle C. So how do we know A minus B, A plus C? So first we get that A plus B. Your A plus B can be solved using the concept of the sum of the angles of a triangle that is equal to 180. Since C is 96, so alright. So we know that A plus B is equal to 84. So we replace that in our law of tangents. So you have 5 minus 3, 5 is A, 3 is for B, all over 5 plus 3 equals tangent 1 half quantity A minus B over tangent 1 half 84. So you need to calculate this with a given calculate with your calculator. So let's see and apply that in our scientific calculator. I'll check if I still have it here. So you clear your calculator. So we have now we have 2 eighths. 2 divided by 8 times tangent 1 half 84. So we can have tangent 42. Oh wait, I think I need to use the parenthesis thing. So again, as what I've said a while ago, you make sure that you are familiar with you're familiar with your calculator. If your calculator is not that equipped with this multiplication, not that equipped with what do you call this? That advanced thing, tangent 42. So equals sine. Sorry. So tangent 42. Let's do it again. So 2 divided by 8. Oops. I think I need to double it. 2 divided by 8. Okay, close parenthesis. Tangent half of 84, so that's 42. Okay, close parenthesis, divide by, we have tangent 1 half, tangent 1 half. So you'll have approximately 25.79. The others might get 25.5 or 25.4. So again, it depends upon the setting of your calculators. Approximately 25 minus P. So that ends my discussions for your law of sines, law of cosine, and the law of tangents. So if you are to check into the reference, God bless. And happy